Stanford University.
All right, so hey everyone. Today we're going to do a fun lecture on designing multimedia iOS apps. We're going to use OpenGL and C++. Don't worry if you don't know either of them, because it's going to be pretty lightweight on those two things today. And we're going to create a fun little demo application. It's kind of a little mini game, so that's going to be the goal of today's lecture, is to do a pretty hefty demo. Actually, there's going to be quite a bit of code, but it should get you guys well on your way. So as I thought about giving this lecture, I thought about giving the kind of common approach to teaching OpenGL on iOS, which is to basically assume that people know something about OpenGL already, and then to kind of enumerate all these ways that iOS OpenGL is a little bit different, because there are some features of regular OpenGL that you can't use on the mobile version of OpenGL. But I decided to scrap that approach for today and to just assume that you absolutely know nothing about OpenGL, and to build a little demo app using this technology so that you kind of can see how it works from the ground up and just get a taste for what's possible. And then the thing that I'm going to build for you today is going to give you the tools that you can use to go learn OpenGL on your own time using all the millions of OpenGL tutorials on the web and incorporate them into iOS through a nice C++ framework. And as well, you're going to learn how to use external toolkits should you have like a C++ external framework that you like using. So a little bit first about OpenGL if you haven't used it before. It stands for Open Graphics Library, and it is incredibly widely used, incredibly powerful. If you've played any video game in the past 20 years, you've probably used OpenGL thousands of times as a kind of client using it. It's really, really, really powerful. So that's OpenGL in a nutshell. However, for iOS, we actually use something called OpenGL ES. The ES stands for Embedded Systems, and the basic idea here is that OpenGL, standard OpenGL, has a lot of features which are just a little too maybe slow for a mobile device, or like if you're not careful, you might mess up and make something really slow or drain battery life or something. So they've created OpenGL ES for embedded systems to make sure that you can't do those things. It's a subset of OpenGL, so you can't use any OpenGL code you find on the web in OpenGL ES, but you should be able to find a lot of lists out there on the internet of what the differences are between the two frameworks. And it's still incredibly powerful. Like you've seen games that you've played on iOS, so you know how powerful it can be. So it's not really a problem, but just wanted to give you a heads up about that. And also, different versions of OpenGL ES have vastly different capabilities, and today we're going to use OpenGL ES 1.1 instead of 2.0 for some reasons I'll get into later. And so yeah, today's demo, like I said, we're going to make a little simple game. It should be a fun thing to learn how to make, and you'll see the immense different ways you could take something using this framework that we create today. It's going to include how you compile C++ into iOS apps, which is not something you've probably done all quarter. It's actually very simple. That's going to be the quickest part of today's tutorial. And I'm going to show you how to incorporate a simple external framework. It's a C++ library that is developed here at Stanford to handle simple things like input handling for your phones, so that you can like have touch callbacks and accelerometer callbacks and audio callbacks and things like that. It's just a nice library and way to do that from C++. And the majority of this demo is actually going to be about object-oriented design best practices for C++ and for OpenGL. And the basic idea behind giving you guys this kind of tutorial is that you're going to go out there and you're going to want to learn how to use OpenGL in general, and you're going to come across lots of tutorials with lots of OpenGL code. But when you actually go to try and code up something of even medium size to large size, you're just going to get into a huge mess. It's very easy to get yourself into a mess using OpenGL when you're first learning it. So the framework I'm going to give you today is going to kind of really do a good job of making sure that you have a very modular way of learning OpenGL as you go out there and try and create some demo apps. So with that, let's actually get into the demo. It's going to be about 45 minutes of a demo, but it should be fun and interactive. We're going to end up with a cool little game by the end of lecture today. So to do that, I have created a skeleton, very bare bones OpenGL application in Xcode. And how I did this, just for your reference, is by going to File, New, Project, and instead of creating a single view application like you're used to, you can click this OpenGL game application. But the problem when you do this is, and I'm not going to do it right now, is you're going to get a lot of starter code inside of the OpenGL view controller, and the app that it creates is going to do some actually pretty complicated OpenGL stuff. And for somebody who doesn't know OpenGL at all, this is going to be really confusing looking in the view controller. You're just not going to even know what's going on at all. So I've stripped out all of that code that they've used to create their sample app and made a completely blank project. So I have this view controller here which only has this much code in it. You see it's very small. to create the OpenGL context within which we can draw OpenGL code. And just so you know, let's get the simulator running. This is what it looks like right now, just a blank screen with some purple color for some reason. And so what I want to do is just describe this view controller that it gives you when you create this starter application. And the basic idea here is that in the viewDidLoad method, we create something called an EAGL, GL for OpenGL context, which is much like the context that you use to draw in Paul's earlier lectures this quarter about drawing the axes and that you used to draw the graph on the calculator. You had to acquire that graphics context. We're doing a similar thing here. It's just a general kind of meta thing that manages state for OpenGL. So that's what the viewDidLoad method does here. It kind of handles creating this context. And then it uses a little external framework over here called the GL kit, which is Apple has created this to be included in iOS apps, where you can kind of have some helper methods for setting the context. You don't really need to worry about this for today's demo necessarily, but just know that that's what's going on, is we're using this GL kit framework so that we can implement two delegate methods. And we're just going to take a minute to explain these two methods right here. There are only two that we're going to implement today. One of them is called update, and one of them is called draw and rect. And that should sound familiar from previous drawing. The basic idea here is that update handles updating the state of your model, basically. So you can think of update as kind of model stuff, and then you can think of draw and rect as kind of view stuff. That's kind of weird because they're in the same file. They're in the view controller here. But as the lecture goes on today, you'll see exactly why all of this is being done. So just remember that these functions get called in a one-to-one fashion throughout your application. So update gets called, then render, then update, then render, then update, then render. And that's how big things like games are created in general. That's how the code is structured. So just know that that's what's going on in a one-to-one fashion. And so yeah, let's get started actually writing some code here. And like I said, we're going to be using C++ today. And to kind of isolate all of that from this view controller here, I'm actually going to create a helper file that's going to be using all and only C++. And we're going to define a public API for that helper file, which we're going to call from this view controller. So basically, we're going to call just a few lines of code from this view controller and then go and implement everything in this other C++ file, if that makes sense. So the public API that we're going to create is going to go into something I'm calling glhelper.h. And since I have a lot of code to get through today, I'm actually going to be pasting a few snippets of code here, just because I don't want to take too much time on mundane details. But basically, we're going to have an initializer, a thing that cleans up, a thing that does rendering, and a thing that updates the model, right? And we'll get more about what this parameter inside update is later. But anyway, that's our public API. It's that simple. And then back in the view controller, we're just going to import this public API. And then we are going to make calls to it from all of these methods so that we can just go into that other file. So the first thing we have to do is when the view loads, we have to initialize that file. When it unloads, we want to clean up through the API. And every time we update, we are going to call this update method. I'll explain more about this in a second. And then in render, we are going to render. So it's that simple. So now we'll be going and doing everything in this other file. Now, there's two catches here. The first thing is this update method, this parameter we're passing. The GL kit gives you this nice value, the time since last update. And this is going to become very useful later on, and I'll explain why inside the file that we're implementing, why we need to handle how long it's taken since the last time we updated. The second thing is that this file that we're creating, you'll notice over here, I have created a .mm file as the implementation for our public API. And you've probably never seen a .mm file before. And this is the key to the C++ puzzle. This is how it works. All you have to do is take any file, like viewcontroller.m, and rename it to .mm extension. And that tells the compiler to compile using Objective C++. So you can literally use both languages in the same file. This isn't a class on compilers, so we don't need to go into that business, but just know that if you want to write C++ code, you can just make something a .mm file. You can also, I think, change it so that M files use C++ by default from like build settings or something like that. But anyway, that's generally what's going on here. So anyway, yeah, now that we have this file is an MM file and we're using an MM file, we should be good to go for C++ inside of the GL helper. So let's take the public API and implement it, which is going to be the purpose of today's lecture, pretty much. That's the goal of today's lecture anyway, is to implement these four methods so that we get some nice OpenGL application that does some fancy fun stuff. So an OpenGL application, I want to create something that shows kind of all of the basic components of like a nice little interactive demo. And one of those things is just being able to draw something on a screen and be able to animate it in some fashion, right? You'll do that in all kinds of different ways, but we're just going to do a really simple one for right now. So as just a simple design for that, what if we just had some little circle or ellipse or something on the screen that's just going to move around in time, right? So we'll get that working first. And you're like, okay, that sounds pretty simple. We could probably write about 20 lines of code in this file right here in order to do that, and we probably could. But part of today's lecture is showing you how to do this in a really scalable, like nice way, so that when we add more objects later on, we can do it all in a very modular, like happy, object-oriented way. So in order to just get this object moving around on the screen, we're actually going to write quite a bit of code. It's going to be maybe surprising to you at first why we're writing so much code. But by the end of the lecture today, you're going to be like, oh, that's really nice. I understand why we did that. So the basic idea here is to create some kind of class, which we're going to call an entity. I have a file here called entity.h. And an entity is going to be an abstract base class for any kind of object that you would ever have inside of like an OpenGL application, right? So entities might share certain things in common, like functionality and data. So the data things in common might be like the location of an object in the world, right? Every object is going to have some location, therefore the base class will just keep track of location. It might also have things like a color, for example, right? So that's kind of nice thing about having shared data so that when we subclass it, we don't have to recreate all these data variables. The other thing is functionality similarities. You'll notice we have these methods inside of the GL helper called render and update, and their goal is going to be to go through all these entities and render them and update them. So the base class, the abstract base class, can just have a render method and an update method that we override from all of the subclasses. So before we actually create this ellipse on the screen, let's create the abstract base class and then subclass it, if that makes sense. Is everyone with me on this? Does this all make sense? Okay, cool. So yeah, the entity H file, again, in the interest of time, I'm going to just paste some stuff, and then it'll make a lot of sense when I actually point out what it's all doing. What we have here in the entity class is we have a basic constructor which does nothing because it's an abstract class. Okay. Then we have 3 virtual purely abstract methods. That's what this is equal to 0 means. You can look this up online if you're not familiar with C++, but it basically means that we're not actually implementing anything on the entity class. We're going to implement it in the subclasses in order to use them. So that's what these 3 methods are. We have a render method, an update method, and a method we're going to use later which handles collisions with other entities in this world. You'll see why that comes in handy later. Then, like I said, we're going to have these member variables, like whether this entity is currently active, or whether it's, you can think of it as kind of like a dead alive kind of thing. Its location, its color, and how much time has elapsed since we first created this entity. Okay? So that's the basic idea behind the base class. The one other thing I'll point out is that C++ is kind of tricky to do introspection. It's not as nice as Objective-C. So I'm going to do a kind of maybe clever little hacky way to do this, which is I'm going to create an enum type def up here at the top that's going to have all the entities types that we can use today in today's lecture, like this orb that we're creating right now, and then later we're going to create one called the bullet. And then the entity type inside the constructor, we'll just always set what its type is. That way we can always just access it later. So that's kind of a cheap way to do introspection. Again, more on that later. So this is our entity class. We don't have an implementation file for it because it's an abstract base class. Okay, so now that we have the entity class created, we can go ahead and create this orb object that we're talking about getting moving on the screen. And the orb object, like I just mentioned, is going to be a subclass of entity, right? So it inherits everything from the entity and needs to override these pure abstract methods that we just defined. One of those was the render method, except you'll notice we've removed the virtual keyword here because we're actually going to implement it on the orb class. Same thing with the update and the handle collision with entity method. And then we've also got this hit test method down here. So we're going to be overriding lots of things from the entity class. Then we're adding some additional member variables, like this guy has a radius and a speed, and we're going to keep track of the y value on the screen that it starts at, for example. So this is our first subclass of entity. And I'm going to implement a few of the methods, the most relevant methods from orb for you. The rest of them are just helper methods. So the constructor for the orb, just know that it sets the type, like I just talked about, right? That way we can do introspection later if we want to know from an entity. If we just have a standard entity pointer and we don't know what type it is, this will tell us. We can just access that member variable. And I'm actually going to implement from scratch the render and update methods of the orb right now so that you can see how they work. I'll do update first. Like I said earlier, update deals with the model of things in the world. So this has nothing to do with drawing or anything. It's just going to have things to do with, like, in this case, we want to move the orb around on the screen, right? So every frame inside the update method, we're going to affect its location. That's the general idea, okay? So how animation works, though, is across time. In other words, we need to keep track of the total time that this orb has been alive. So you'll recall that the entity class earlier, we declared this member variable called total time, a floating value, okay? And then in the orb's update method, we'll just say every single frame, we know the time since the last update, we'll just add it to the total time. Does that make sense? Cool, so now we have mTotalTime to use inside this method as just the total time since we instantiated the orb object. Okay, so the next thing we're going to do inside update is actually affect the position of the object, and just as a simple design, what we'll do is have it sinusoidally move from left to right and up and down around the screen, kind of like it's avoiding getting hit by something. Hint, hint. We'll deal with that later. So to do that, all we have to do is put a sign function with the total time as one of the parameters so that over time it just goes back and forth. And we're going to have it go from a negative 0.7 to 0.7 on the x-axis because our screen is going to go from -1 to 1, so it's just going to go left and right in the middle. And we're going to do something very similar for the y value. We're going to take its initial y value that we set in the constructor, and we are going to move it sinusoidally also according to its speed and the total time. So that's pretty simple. Then in the render method, all we're going to do for the orb is write your first bit of OpenGL code if you've never seen OpenGL before. And I need to step back for a second and explain something about OpenGL before I do this. And that is that OpenGL is a gigantic state machine. And what I mean by that is you can think of calls in OpenGL as belonging to two categories. One of them is where you set the state of the OpenGL library. And the next category is where you actually go and do an action, like draw something, right? And whenever you go and draw something, odds are that drawing is happening based upon like 10 or 20 of the states that are currently set in the library. So this can be really confusing when you're first learning OpenGL because in some file over here, somebody has set the state of transparency to be one thing. And then in this file, like way over here, hundreds of lines later in your code, right, somebody else is drawing something and it's happening because of that state over there. So that's kind of very confusing. So you have to set the state first every time that you want to draw something. In this case, we want to set the color of the orb to be the color of its member variable that we had in the entity class, right? We created an RGB and alpha in the entity class over here, this guy right here. And we're going to use that color here. So this sets the current state of OpenGL, but doesn't actually draw anything. So it's just saying, from this point forward, anything that gets drawn will be drawn according to these values. And since those values here are all 1, that's white in this case. So anything that ever gets drawn on the screen right now is going to be white once we've executed this line of code. Then I don't want to get too much into the details yet about OpenGL drawing, so I just have a little helper method which is going to draw a circle. And I'm just going to give it a center of the circle to be the location of this object in the world, right? These variables right here from the entity class, its location. And then it's giving me auto-completed stuff. And then I want it to be filled in with the color that is specified. All right, great. So that's it for render. So I mean, this is it for the orb class. These are the two important methods, or update and render. And then if we want to actually show this thing on the screen, of course, we have to go back to the GL helper and implement our API here. So in init, what if we just created a simple orb object? We'll create a global for now. We're going to change this later. But what we'll do is say, create a new orb at location 0 on the x-axis and 0.6 on the y-axis. And then we're going to set its speed. There was a method on orb called setSpeed, which we're using this global variable difficulty to set. So it's set to 2 right now because the difficulty is medium, for example. So now we have an orb that exists. Then in the cleanup method, of course, we'll just delete the orb. Oops. And then in the render method, we will do the same thing, except a render. And in the update method, we need to pass through this time since the last update. So that's it. That's it for the orb. Do we have any questions so far? This would be a good stopping point. Is this clear to everybody? Okay, good. So let's run this application and see what happens. We should expect to see an orb moving around on the screen. So it worked, sort of. We have a little bit of a problem, which is that the orb just keeps drawing every single frame. I'm showing you this problem to draw a distinction between set needs display and draw rect, which you're used to, and that is that it just draws the entire screen again. But in OpenGL, you actually have to explicitly tell it to clear the screen every frame before you redraw. So that's what we didn't do. That's why we're seeing this kind of mess right here. So all you have to do that, just like when we set the color and drew before, is you have to set the state of the clear color, as it's called, which is basically the background color when you clear the frame. So all we're going to do is say GL clear color, and we're going to give it black for the background of the screen. And then you have to actually go ahead and clear, based upon that state, the screen. Don't worry too much about what this line of code is doing as far as parameters go. You'll have to learn OpenGL in a little more depth to understand. But basically, we're just clearing the color and this other thing called the depth buffer, which handles which objects are in front or behind other objects. Since we're doing something 2D, it doesn't really matter in this case. But that's what's going on with those two lines of code. So with that fix in place, we should see our little orb moving around on the screen happily. Cool. So now we've done the first part of kind of an interactive multimedia app, albeit in a very basic fashion. We've got this mesmerizing little circle scooting around doing nothing. And it really, really, to my boyish eyes, looks like it wants to get shot by some bullets. So I think we'll do that next. All right? That's kind of the last fundamental piece to an interactive application, actually, is interacting with the screen in some way and seeing some cause and effect relationship. So thinking about this application as a simple design for what we're going to do next, how about we click on the screen, we touch on the screen anywhere down here at the bottom, right? Maybe with multiple fingers at once. And every time our finger goes down, a little projectile will spawn out of nowhere, and it'll launch upwards towards this thing at the top of the screen. And then what would be even cooler for cause and effect is maybe if one of them hits the orb, something happens. In this case, how about whatever the color of the projectile is, the orb just takes on that color. So that seems like a nice, simple little way to get interaction going, right? I know I've just hypnotized everybody with this orb on the screen. You'll have huge eyes out there right now. But yeah, let's do that next. Like we did before, getting that orb moving around on the screen, we're actually going to write quite a bit of code to do this. You might think there's a simple way to just create little projectiles and have them hit this orb. But if you think about this from a more object-oriented perspective, now that we're adding multiple different types of entities to the scene, it would be really nice if there was some abstracted class that kind of handled all of these things, all these interactions between entities for us. This is commonly called a scene manager in game design, for example. So what we're going to do is create some class called, we'll call it the world class, that's what I like to call it, and the world will own all of the entities. So in this case, the orb will no longer be a global variable of this little GL helper file here. It'll go into this entity manager file, right? And so will all of these little projectiles. Everything will be managed by the world class. Does that make sense to everybody? Are there any questions about why we would do that? No, okay, so everyone's on track with that, so that's great. Then the next thing we're going to have to do is think about the fact that these bullets are going to, these little projectiles are going to be interacted with by touching, okay? And since they're interacted with by touching, unlike the other orb, it might be nice if we took our abstract entity class from earlier and had yet another abstract class, which we might call a touch entity, which subclasses entity and handles all the additional touch logic. Does that make sense? Okay, good. So let's go ahead and first, this is very simple, so let's go ahead and create this touch entity class. And we will subclass the entity, the abstract class right above it. Entity. And it will just have some very simple things. We're going to give it a UI touch reference, which will come in handy later when we implement the actual touch logic. And we're going to give it a method called deactivate. And all of this deactivate method is going to be used to do is whenever a bullet leaves the top of the screen, we want it to be able to be shot again because we're going to have a fixed size number of bullets in the world at any given time. So that's what this method deactivate is being used for, when it leaves the top of the screen or when it hits the orb, something like that. And then we want to make sure that its touch ref is reference to the touch object is able to be accessed again. So anyway, that's it for touch entity. So now with this projectile class that we're about to create, we can just subclass touch entity and it'll have this additional behavior. So let's go over into this next class. Again, you've seen me create the orb class earlier. So I'm just going to go ahead and paste in this this header file because it's really basically the same thing as before. Okay, it has the exact same things as before. It's got a constructor, a destructor. It's got these implemented overriding methods of the abstract class, the entity class, right? It's got a render, an update, a handle collision with entity method, which we're not going to be using, and it's overridden the hit test method. Additionally, we have this feature where every time you tap on the screen, it's going to have a new color. So I have a helper method which randomizes the color. Big deal. So this is pretty easy for the interface for the bullet class. As for the implementation of the bullet class, we're actually going to implement a few of the methods just like we did with the orb implementation earlier. So I'm going to delete a few of these things. Like before, I'm going to implement the render method and the update method, the two most important methods, from scratch. If you have any questions about OpenGL that I'm not answering as I go through the render method, please let me know. But I will try to answer them because we're actually going to write some OpenGL drawing code this time. The first thing we're going to do is say that if a bullet is not currently active, right, we don't actually want to draw it. So let's just get out of this method. Simple. The next thing we're going to do, just like we did with the orb, is we're going to set the state based upon... there's one thing I want to explain real quick. You may have noticed that out of all the methods in the entity class that we declared earlier, we put this const keyword at the end of render. In case you're not familiar with C++, what this means is any of these member variables on the class, if we're inside a method that has this const suffix on it, they become read-only. They cannot be changed. This is along the lines of model view controller, where the view can't actually change the data in the model. Because it would be very bad if we were inside the render method and someone decided to set the position of our bullet from the render method. That doesn't make sense. That's not the point of the render method, right? So that's why that const keyword is there, just FYI, in case you don't know that about C++. So anyway, we're going to set the state of the of our projectile by color first, and then we're going to have some helpers which are going to compute half of the width and half of the height of the bullet, because that's what we're going to use to actually specify the vertices in the world. Oops, excuse me. And this is how drawing is going to work in OpenGL ES, or it's one of the many ways that drawing can work in OpenGL ES. Instead of just starting some kind of shape and then specifying vertices as you go along and then ending the shape, like you might be used to in some drawing libraries, you can't actually do that because the standard way to do that in OpenGL is disallowed by OpenGL ES. I think for reasons that you have to pass the data constantly back and forth between the CPU and the GPU, so that's slow, and so they disallow things like that. That's called drawing, if you're familiar with OpenGL, that's called drawing in immediate mode. And you might be used to saying GL begin and then specifying vertices and saying GL end to draw a shape. You can't do that in OpenGL ES. So I'm writing this code right now just to inform you that OpenGL ES is a little bit different. And so you have to specify an array of all the vertices first, and then later tell it in an intelligent way how those vertices are being used to draw the object on the screen. That's what's going on here. So what I'm doing right now is creating the first of 3 vertices for this little triangle that we're going to create. This is in like X, Y, Z fashion. There's no depth, so Z is just 0. And so for the X value, we're just saying where the object is minus half of the width and then minus half of the height, right, for the first vertex. And then we're going to do likewise for the other 2 vertices. Okay, great. So we got this array specified. Sorry, that takes a while. Now we're actually going to write the OpenGL code. It's just 3 lines, 3 quick lines to actually make sure this shows up on the screen. The first thing we have to do, like I said before, there's this whole state business of OpenGL. We have to tell OpenGL that the client state to be able to draw these arrays of vertices is enabled. So that's what this line is doing. It's saying we're enabling OpenGL to draw vertices in this fashion. Then we have to give it a pointer to these vertices. There's 3 of them, and they're floats, as we just declared them. And this is the name of the array. Whoa, vertices. And then finally, let's actually put them onto the screen, into the buffer. And we're drawing a triangle, right? So we're going to tell OpenGL, this tells it what type of shape to draw. You can give it quads or triangles, and you can look up online what all the various ways are to draw different shapes in OpenGL, but we're drawing a triangle for now with 3 vertices. Anyway, so this is the code to draw in OpenGL. I'm going to post a link to the slides that gives a list of big OpenGL ES tutorials, and you can go through those to your heart's content and figure out how to draw various types of objects, but this is the basic idea for a simple shape. So now the model stuff, the update method. The update method of the bullet class is going to do the following. We wanted it earlier, remember in the little orb moving example, we wanted it so that when you tap on the screen, a bullet just launches upward from the bottom of the screen, right? So every frame, we just want to increase the height of the bullet, its Y position, by whatever the speed of the bullet is at that time. That's all that the model is handling in this case. And then when it leaves the top of the screen, we want to deactivate it so that it can be used again in the future. So that's what the update method's purpose is. Just like the render method, if it's not active, we don't need to deal with any of this. If it is active, however, we want to move it upwards on the screen by just a little bit. So I have some nice numbers that I know are going to work here. And there's one key concept in this line of code which is worth pausing and explaining because it hasn't happened yet. You'll recall from all the way back from our view controller, inside the update method, we pass through this time since last update value. So that's the last time that update was called. It started a little timer, and then it's passing through that value this time around. Okay, that's getting passed all the way through our API to this bullet method. Okay. The reason that we're multiplying how much we move the location by time since last update is as follows. And you should, if you're watching out there, pause the video and think about this. This is very important. The basic idea is maybe somebody is playing our little application on an iPod Touch. Somebody else is doing it on an iPhone 3. Someone else is doing it on an iPhone 4. Someone else on an iPhone 4S. All these different devices. They've all got different processors and different processing speeds, right? So if we're just to hard code a value by which the amount goes up, the update method might get called more frames per second, for example, on someone's device. So this is a very platform independent way of saying if we multiply how much it moves by how long it took to call the update method, it'll happen the same across all different processing speeds. This is really common. You have to do this thing in game design, basically. So that's why this is being multiplied by time since last update. If you forget that, you will have very frustrating problems. The next thing we're going to do is just when the bullet leaves the top of the screen is a Y value of 1.0. Maybe when it gets to 1.1, we're going to say deactivate, which was on the touch entity class that we specified earlier. And then we'll keep track of total time, just like we did in the orb class earlier. Even though we're not using it here, it's always something that's useful to have in case we ever wanted to use it later. Maybe bullets that have existed for a certain amount of time, something special needs to happen to them at some point. So we're just going to keep track of total time the same way we did. So anyway, that's really it. That's it for the render method and the update method of this class. So now that we have this bullet object, let's revisit that idea I talked about, which was we have multiple types of entities going on the screen right now. We have an orb subclass, we've got a bullet subclass. How on earth do they interact together? One way to do this would be to go into our GL helper file, the main one, and to create another set of global variables for all of these projectiles, and then to handle all the logic for how they interact with the orb inside update. But wouldn't it be nice, like I said, if we had this kind of manager for entities? So let's go ahead and create that thing, and that entity manager will take over all the grunt work in this file at the high level, and then we can implement all the gory details inside that thing. It's a nice way to make everything very modular. So like I said, that thing will be called the world file, and it's got a very simple interface, so I am actually going to paste this in the interest of time. You can go look at any details that don't make sense now later when I post the code. But the basic idea is, like entities, even though this is not an entity, it has a render method and an update method, right? And their responsibility will be to render all of the entities that they manage and update all the entities that they manage in some intelligent way, right? Then we're also going to have a simple way to add an entity into this manager object, right? The last thing is a helper method we'll implement later about handling collisions between all the entities. Because like I said, when the bullet hits the object, we want it to change colors or something like that. Okay, and then for now, what we're going to do is have the entity manager own the entities in a very simple data structure, which is a vector. So it's just going to have a little linear list of them. If you're creating some really complicated game or complex application where there needs to be some like optimization because you have a lot of things going on, there are tons of data structures out there. You can look up online scene graphs to see how these things are usually created and managed. But for today's application, we're just going to use a vector of the entities because it's going to be super fast and efficient to just code it with linear search through this vector of entities. So anyway, that's the interface for our world class. Now, as for the implementation of the world class, what we're going to do is implement maybe one or two of these methods right now because they all do very, very similar things. And it should be very clear what those are. The first thing I want to implement for you is the constructor of the world class. And the idea here is that we're not actually going to dynamically create a new bullet object in code every time somebody taps on the screen. What we're going to do is take advantage of the fact that the iPhone has a maximum ability to register 5 taps at once. The iPad has a maximum ability to register 11 fingers. So yeah, I don't know why it's more than 10. I guess if 2 people are using it or something. Or cats or something. I don't know. But so yeah, because we're making this app for the iPhone, you'll notice that the max bullets constant here is set to 5. I'll put a comment here, up to 5 on iPhone, 11 on iPad. We're actually going to go through and create 5 bullet objects. Just like that. And then it's that active state thing in the deactivate method that's going to handle the current state of those bullets. So that's why that's working the way it is. The next thing I want to implement for you is the update method. Basically, all of these methods are just going to iterate over the array of the vector of entities and do something to each entity. So in this case, in the update method, all we're going to do, just like we just did, is iterate over entities in the world. We are going to grab whatever the current entities in the vector is. We're going to make sure, just for sanity's sake, that it exists in case one of them gets set to null by some evil client or something. And the next thing we're going to do is, before updating every entity individually, its position and state, we're going to handle collisions, which is going to add a little bit of additional logic for when the bullet hits the orb on the screen. So I have a helper method which does this. And basically it's naively implementing this method by basically saying, given this entity in the vector, iterate over all the other entities and check those versus this one. So we're actually doing a lot of kind of redundant work there, but it's the easiest way to code it up for now in the time we have. And then we're going to update the entity with the time since the last update. So this is nice. This update method now handles updating for every entity in our entire world. And the other render method does the same thing. It just renders all of the entities. And then back in our GL helper file, rather than do this messy orb business here, we're just going to have only ever one global called gworld, a pointer to the world that we're in. We're going to create a world when we initialize this GL helper. We're going to add an entity, an orb entity, just like before, to the world. This is just what we did before, except that we're going to actually add it. And then when we're done with this GL helper, all we have to do is delete the world, right? Because the world's destructor can just handle deleting all of the entities inside of it. So it's a nice clean way to just handle all of your world's entities in one spot. Likewise for render, we're just going to render the world, which will magically handle all the rendering for all the entities. And finally for update. Okay, Great. So now to pause and reflect for a moment, you see this nice kind of boiling down fashion where we've started from the view controller. We've created this public API to this GL helper class. We've created a world class, which is handling updating and rendering. It's doing all the complex logic for managing all these entities using the magic of polymorphism to figure out which one is which. And then those things are responsible for implementing all their gory details. So this is a very nice like step-down layering process of all this stuff happening. As your app grows in size, as you have like 50 different types of entities and they're all doing various types of interactions, this is a super nice framework to have in place. In fact, I'd venture to say that once your app hits a certain size, you couldn't even get it all working in one file because the OpenGL code just gets too messy. There's too many states being set, all over the place, and it's just a real mess. So this is a really nice modular way of handling all these things. This is one of the main things I want you to get out of kind of today's lecture is when you go off and learn OpenGL and other external frameworks, that you have some nice framework like this to put your code into so that you can kind of do things in a very clean object-oriented type of way. So okay, great. We've got this world created now. The last thing is we have to handle all the logic for the touching and for how when the actual bullet hits the orb that the color of the orb gets changed and stuff like that. So the last piece to the puzzle of the interaction. So the first thing we're going to do is go back to this won't make complete sense why we're doing this right now. You'll have to wait to see in about 2 minutes why we did this. But we're going to put a helper method on our world class, which is going to say, at any given point, I should be able to find an inactive bullet because we want to be able to use an inactive bullet to launch from a new finger that goes down on the screen. And if there isn't a currently inactive bullet, we're just going to return null. So that's what this method find inactive bullet does. And remember, each bullet has its own touch reference. So we're going to be passing it a touch when the finger goes down on the screen. Then inside the actual world file, we will say we'll implement this method as follows. We're a little bit short on time, actually. We're almost done, but I'm going to go ahead and copy this implementation just to explain at a high level what it's doing. All we basically do is iterate over the entities and check for each entity if it's a bullet, right? That's why we created that type thing on the entity class earlier for kind of cheap introspection. And if it is a bullet and it's not currently active, we're going to give that bullet back. If we don't find an active one, we just return null. That's all this method is doing. It's very simple. The last thing we have to do before we implement the touch logic is in the orb class. We have to somehow handle the collision with the bullet. So all we're going to do here in the orb class is just say, when an entity collides, it goes into this method with the orb, right? If it's not a bullet, we don't care because we're not handling any other objects colliding with this orb object. And then we're going to say, if that object is not within the bounds of the actual orb, right? If it's like over here on the screen and the orb is over here, then we don't want anything to happen because it didn't actually collide, right? But if those two things are the case, we know that a bullet has entered the space of the orb, and that bullet has a certain color. So all we have to do is set the color of the orb, which we're inside of right now, to the color of the bullet. So that's what these 4 lines are doing right here. So that's just the simple collision logic for the orb. Okay, so that's it for handling the collisions. The very last piece to the puzzle is, back in our GL helper, we need to actually handle the touches happening on the screen. So to do this, I mentioned in the slides at the beginning of lecture that one of the things you're going to be doing when you create a big multimedia application is using external frameworks. You'll probably have like either a game engine or a physics engine or probably more than one thing, maybe a rendering engine also. You never know what you're going to be using. But a lot of those things will require you to implement like callback methods for various things. So in this case, I've used a very lightweight library called the MOMU library. The mobile music library actually is what it's used for, but it has a very nice lightweight touch callback. So I'm going to use that to implement touches. And the way it works is, all you have to do is include this file motouch.h, which I've included already for you, and then inside the init method of our GL helper, all we have to do is just add a callback method to the touch callback. We're not passing it any data. And then we just have to go implement that callback method. And it looks like this if you look in API for this library. It gives us an NS set. Notice we're mixing Objective-C code into C++ code here. That's totally fine. Don't worry about the gory details that we're not going to use of the rest of the callback header. So this is the touch callback provided to us by the MoTouch library. And again, in the interest of time, I'm just going to look at a high level. We're almost done. At what this method does. And all it does is it says, whenever this is called asynchronously on its own thread, it gives us an NS set of touches, right? So all the fingers that are currently down on the screen, maybe 3 of them just went down, okay? And recall that when you're on a device, if you're dragging your finger around, every time your finger moves a little bit, it still registers a new touch. But that's a kind of touch that we're not interested in right now, because when we move our finger around, we don't want bullets to just appear as we drag around. We only care about when the finger goes down on the screen, right? So that's a different type of touch event. So nicely, this gives us a touch.phase variable here, which we're checking is equal to UI touch phase began. So that's all we care about. So if a touch phase began, what we're going to do is convert the coordinates of where the touch happened on the screen into the OpenGL coordinates, which are from -1 to 1 on both the x and y axes. And then we're going to use that helper method we just created to find an inactive bullet on the screen. And if we find an inactive bullet, which means we can launch a new projectile, we're going to set it to be active and give it its touch reference, and then set its position to be where the touch happened, and give it a random color to be launched, right? And then all of this other entity managing business is already handled for us by the world. So that's all we need to do from within the touch callback. So when we run this now, we should be able, barring any issues, to shoot these little guys. It took a long time to write all that code, but it was done in a very clean way. So you can even shoot like multiple ones at a time, right? Because of the way this touch callback works, right? You can put up to 5, like we described. And then finally, if you're actually talented enough to hit this giant target, the color that gets generated by the this is mesmerizing, I know. The color that gets generated by each bullet is transmitted to the orb. Okay, so this is kind of all of the fundamental components of an interactive application using OpenGL. We've got all this model information going on, being updated frame by frame. Then the render methods are all happening based upon what the model is, but unable to change it. And it's happening in a very layered fashion, from worlds to this abstract class entities to all the subclasses of entities. We've got orbs, in this case, and bullets, right? And it's all happening in a very nice, clean, dynamic way. So yeah, that's basically it. Are there any questions before we go about anything we covered today? Yeah?
Where do you activate the touch events?
Where do you activate the touch events?
Yes, you just had that callback, but you didn't activate the touch event.
So it handles that for you. This method, the touch callback, the question is where do you activate the touches, if I'm understanding? And the touch callback is polling constantly on a separate thread. That's how the MoTouch library is implemented. And every time a touch happens, it enters this touch callback with an NS set of touches, right? So all you have to do is just iterate over the set of touches for that current poll, and it's fine. Most of the times that this method is here, like maybe there's no touches in the set or only 1 or something like that, but there could be up to 5. That's how this method works. Sorry, maybe I should have explained that. Does that make sense? Anything else? Okay, well then I have one more slide just to show you guys, just so you know that it exists. And by the way, all that code will be online, so you can just go through all the gory details if you missed something. And this last slide here is basically the best link I could find on, I gotta go through everything. The best link I could find on tutorials to OpenGL ES as it relates to iPhone is listed at the top here. So if you don't know any OpenGL and you want to go learn all the fun stuff, that's a great place to start. There's also a million OpenGL ES tutorials around the web. Just look for what meets your needs for your particular. I mean, the best way to learn OpenGL is not to like open a manual and just like read a bunch of stuff and then have mad skills. It doesn't really work like that. You kind of need to say, I wonder how you draw an image on an object, and then go look that up. And it's this very back and forth reference demo app process. So that's a good link for that. And then as for external frameworks, I gave you an example of a really popular game engine called Cocos 2D. So that's a nice way to start with some sample code if you want to like look at how a bigger application might work. And then I've also included a very popular 2D open source physics engine link here that a lot of you guys might find a good starting point if you wanted to build something that involves physics in some way. So yeah, that's it for today. I hope you guys learned something useful. Thank you.
Isn't there also some CS class that does OpenGL?
Oh yeah, I should mention that to everyone in the room, actually. So if you really want to learn OpenGL, there's actually it's a track now. It didn't used to be, but it's CS 148 and 248. I've taken both of these. 148 is taught by Pat Hanrahan, who's an awesome lecturer. He's one of the Pixar founders guys. So he's well, not a founder, but he built basically all the technology originally. So yeah, it's a really cool class, and it's basically a survey class. It's like every week you do a graphics project using OpenGL that does something like totally different from every other week. 248 is like, basically think of 248 as like if you really want to know how to build a really complicated, nice, modern-looking 3D game, take 248. Of course, you don't have to build games. You can build other things, but like that's what 248 is about. You do a big final project where you actually build a 3D game. So yeah, you should check those things out. 248 is not to be taken lightly. Like only take that if you don't have much else to take that quarter, because that's a pretty tough class. But yeah, that's how that works.
For more, please visit us at stanford.edu.
Learning OpenGL as you go out there and try and create some demo apps. So with that, let's actually get into the demo. It's going to be about 40-45 minutes of a demo, but it should be fun and interactive. We're going to end up with a cool little game by the end of lecture today. So to do that, I have created a skeleton, very bare bones OpenGL application in Xcode. And how I did this, just for your reference, is by going to File, New, Project, and instead of creating a single view application like you're used to, you can click this OpenGL game application. But the problem when you do this is, and I'm not going to do it right now, is you're going to get a lot of starter code inside of the OpenGL view controller, and the app that it creates is going to do some actually pretty complicated OpenGL stuff. And for somebody who doesn't know OpenGL at all, this is going to be really, really confusing looking in the view controller. You're just not going to even know what's going on at all. So I've stripped out all of that code that they've used to create their sample app and made a completely blank project. So I have this view controller here, which only has this much code in it. You see, it's very, very small, to create the OpenGL context within which we can draw OpenGL code. And just so you know, let's get the simulator running. This is what it looks like right now, just a blank screen with some purple color for some reason. And so what I want to do is just describe this view controller that it gives you when you create this starter application. And the basic idea here is that in the viewDidLoad method, we create something called an EAGL, GL for OpenGL context, which is much like the context that you use to draw in Paul's earlier lectures this quarter about drawing the axes and that you used to draw the graph on the calculator. You had to acquire that graphics context. We're doing a similar thing here. It's just a general kind of meta thing that manages state for OpenGL. So that's what the viewDidLoad method does here. It kind of handles creating this context. And then it uses a little external framework over here called the GL kit, which is, Apple has created this to be included in iOS apps, where you can kind of have some helper methods for setting the context. You don't really need to worry about this for today's demo necessarily, but just know that that's what's going on, is we're using this GL kit framework so that we can implement two delegate methods. And we're just going to take a minute to explain these two methods right here. There are only two that we're going to implement today. One of them is called update, and one of them is called draw and rect. And that should sound familiar from previous drawing. The basic idea here is that update handles updating the state of your model, basically. So you can think of update as kind of model stuff, and then you can think of draw and rect as kind of view stuff. That's kind of weird because they're in the same file. They're in the view controller here. But as the lecture goes on today, you'll see exactly why all of this is being done. So just remember that, yes, 1.1 instead of 2.0 for some reasons that I'll get into later. And so yeah, today's demo, like I said, we're going to make a little simple game. It should be a fun thing to learn how to make. And you'll see the immense different ways you could take something using this framework that we create today. It's going to include how you compile C++ into iOS apps, which is not something you've probably done all quarter. It's actually very simple. That's going to be the quickest part of today's tutorial. And I'm going to show you how to incorporate a simple external framework. It's a C++ library that is developed here at Stanford to handle simple things like input handling for your phones, so that you can like have touch callbacks and accelerometer callbacks and audio callbacks and things like that. It's just a nice library and way to do that from C++. And the majority of this demo is actually going to be about object-oriented design best practices for C++, and for OpenGL. And the basic idea behind giving you guys this kind of tutorial is that you're going to go out there and you're going to want to learn how to use OpenGL in general, and you're going to come across lots of tutorials with lots of OpenGL code. But when you actually go to try and code up something of even medium size to large size, you're just going to get into a huge mess. It's very easy to get yourself into a mess using OpenGL when you're first learning it. So the framework I'm going to give you today is going to kind of really do a good job of making sure that you have a very modular way of
Stanford University.
All right, so hey everyone. Today we're going to do a fun lecture on designing multimedia iOS apps. We're going to use OpenGL and C++. Don't worry if you don't know either of them, because it's going to be pretty lightweight on those two things today. And we're going to create a fun little demo application. It's kind of a little mini game, so that's going to be the goal of today's lecture, is to do a pretty hefty demo. Actually, there's going to be quite a bit of code, but it should get you guys well on your way. So as I thought about giving this lecture, I thought about giving the kind of common approach to teaching OpenGL on iOS, which is to basically assume that people know something about OpenGL already, and then to kind of enumerate all these ways that iOS OpenGL is a little bit different, because there are some features of regular OpenGL that you can't use on the mobile version of OpenGL. But I decided to scrap that approach for today and to just assume that you absolutely know nothing about OpenGL, and to build a little demo app using this technology so that you kind of can see how it works from the ground up and just get a taste for what's possible. And then the thing that I'm going to build for you today is going to give you the tools that you can use to go learn OpenGL on your own time using all the millions of OpenGL tutorials on the web and incorporate them into iOS through a nice C++ framework. And as well, you're going to learn how to use external toolkits, should you have like a C++ external framework that you like using. So a little bit first about OpenGL, if you haven't used it before. It stands for Open Graphics Library, and it is incredibly widely used, incredibly powerful. If you've played any video game in the past 20 years, you've probably used OpenGL thousands of times as a kind of client using it. It's really powerful. So that's OpenGL in a nutshell. However, for iOS, we actually use something called OpenGL ES. The ES stands for Embedded Systems, and the basic idea here is that OpenGL, standard OpenGL, has a lot of features which are just a little too maybe slow for a mobile device, or like if you're not careful, you might mess up and make something really slow or drain battery life or something. So they've created OpenGL ES for embedded systems to make sure that you can't do those things. It's a subset of OpenGL, so you can't use any OpenGL code you find on the web in OpenGL ES, but you should be able to find a lot of lists out there on the internet of what the differences are between the two frameworks. And it's still incredibly powerful. Like you've seen games that you've played on iOS, so you know how powerful it can be. So it's not really a problem, but just wanted to give you a heads up about that. And also, different versions of OpenGL ES have vastly different capabilities, and today we're going to use OpenGL